So 3D Bioface is a project funded by the Scarfree Foundation. The end goal for this project is to be able to 3D bioprint ears and noses for people who have facial scarring. We can take a very small tissue sample, sort of the size of a hole punch, and then isolate the cells out and then 3D print you a bespoke custom implant that is made of your own living tissue. My role day to day is mostly playing with jellies and playing with gels. And so what I do is I use these gels and I put them through our 3D printer and then build those up into these complex shapes. The printers we use work on very much the same basic principles that a sort of domestic 3D printer will have. The sort of key difference is a lot of these use a long plastic filament that's sort of fed in through a heater unit that sort of melts the plastic and comes out. Melted plastic's not very compatible with cells, so we can't use that technique. So what instead we use air pressure, and we basically have the gel inside a cartridge and then we put air pressure on and sort of blow it out. The other things that we need to understand is the parameters that the construct needs to undergo to survive the surgical process. So we need something that can not only survive being implanted in a human being, but also withstand the suturing, the sort of like the manhandling of actually getting that into the site. This is a material that has to support life. It has cells embedded within it. So we need the cells to survive the process as well as thrive in it and continually remodel the construct after culturing.
Currently, we use a bioink formulation that's made with nanocellulose material extracted from tunicates, which are marine animal. I've been looking at the biocompatibility of the material. So we've incorporated chondrocytes, which are the cells that we isolate from the cartilage material from patients, into the bioprinted material and looked at their viability in the short term and the long term, that they're able to grow and produce collagen, which is going to add strength and structure to our 3D bioprinted scaffold.
Having like a clinically led team has sort of informed a lot of our research decisions. Not research for research's sake, it's this is a problem, what is the best way to fix it, by using both the surgical side as well as the science side. If you take this approach, you don't have to undergo very invasive autologous harvesting techniques where they take cartilage from other places, such as your ribs, and then use that for your ear and your noses.
We hope that this will be the new way forward, the new gold standard for surgical reconstruction. We'll be able to minimize or entirely remove creating additional scars on people.
I love this field. I love the complexity of the problem and being able to actually attack it, knowing what I'm doing has real world tangible effects on people later down the line. And there's a clear goal to this project. So it's quite reassuring for me to know that actually what I'm doing does hopefully one day make a difference.